Hey everyone, how's it going? In this video, we're going to work on an example of using the rational root test to find all of the roots of a polynomial that goes up to the third power. So the polynomial we have is 2x cubed minus 5x squared plus 18x plus 45. So generally, if we have a quadratic equation, there's a lot of tools that we can use. We can either do guess and check, we can use the quadratic equation, the quadratic formula. But when we have our highest power being the third power, it's a little more difficult. So something we can use actually is called the rational roots test. And what that involves is taking all of the factors of the constant and all of the factors of the coefficient of the highest power and dividing them and trying to plug it in using synthetic division. So what are all the factors of 45? Well, we have 1, 3, 9, 1, 3, 5, 9, 15, and 45. And now, what are the factors of 2? Well, that's just 1 and 2. So the way synthetic division is going to work is we're going to write down all the coefficients that we have here. So we have 2, -5, 18, and 45. And then what we're going to do is plug in, what's going to go in here is actually factors of 45 over factors of 2. So for example, let me try, so a factor of 45 is 3, and a factor of 2 is 1. So I'm going to try plugging in 3 over 1, or just 3. So let's see what this is going to give me. The 2 drops down, and then we do 3 times 2, which is 6. We add these. -5 plus 6 is 1. 3 times 1 is 3. We add these, we get 21. And now 3 times 21 is 63. We add these and we get 108. Now, unfortunately, 108 proves that 3 is not a factor of this, because in order to be a factor, we're looking to get 0 right here. So let's try again. We're going to have 2, -5, 18, 45. And this time what I'm going to plug in is the same 3, but this time I'm going to do it over 2. So I'm going to plug in 3 over 2. 2 comes down. 3 over 2 times 2 gives us 3. We're going to add these. -5 plus 3 gives us -2. 3 over 2 times -2 gives us -3. We're going to add these. 18 plus -3 gives us 15. Now 15 times 3 over 2 is going to give us 45 over 2. And once again, that is not going to give us 0. So let's try this one more time. We're going to have 2, -5, 18, 45. And then what I'm going to use this time. So are these all the factors of 45 and 2? Well, not really. What if I have -1 and -45? Well, that would also give me positive 45. So all of these should be plus minus, as should all of these. So now what I'm going to try to plug in is, let's do positive 3 over -2. So if I do -3 halves, the 2 drops down. -3 halves times 2 gives us -3. We add these. -5 plus -3 gives us -8. -3 halves times -8 is going to give us a positive 12. Now 12 plus 18 gives us 30. 30 times -3 halves is going to give us -45. And look what we got. 45 minus 45 equals 0. So what we just found is that -3 halves is a factor that we can plug in to this polynomial that'll give us a factor. So the way we're going to write this is we're going to see what binomial can I plug this into to give me 0. Well, I can plug that in for x plus 3 over 2, and that's going to give me 0. So this is going to be our first factor. And interestingly enough, the leftover that we have right here when we solve our synthetic division, that's actually the coefficients of kind of the other factors when we drop down a power. So originally we were like, this is cubed, squared, 1 power, and then constant. Well, now this is going to be our 2x squared minus 8x plus 30. So now all we have to do is factor this. So what's this going to give us? Well, you could either guess and check. What I like to do, though, is just jump right into the quadratic equation. So that, if you're not familiar with it, is minus b plus or minus the square root of b squared minus 4ac all over 2a. So if we were to start plugging in, we would get 8 plus or minus the square root of 64 minus 4 times 30 times 2 all over 2a, which is just 4. Now, if we solve this, we get 8 plus or minus the square root of 64 minus 4 times 30 is 120, times 2 is 240, all over 4. This simplifies down to 8 plus or minus the square root of, we are going to do 64 minus 240, and that's going to give us negative 176 all over 4. Now, obviously we can't take the square root of a negative number, so we're going to break this up, and we're going to get 8 plus or minus square root of 176, and we're going to have a little I out front here, all over 4. And now we're going to try to factor this out and see what we can pull out front of the square root. So 176, we can divide that by 2. If we do 176 divided by 2, that's going to give us 88. 88 breaks down into 22 and 4. This is 2 and 11, and this is 2 and 2. So I'm going to rewrite this as 8 plus or minus I times the square root of 2 times 2 times 2 times 2 times 11 all over 4. And I can pull pairs out. So I have 2 and 2 and 2 and 2. So I'm going to pull 2 2's out front. We get 8 plus or minus 4i square root of 11 all over 4. Now, we have an 8 here and a 4 here. So what can we factor out? We can factor a 4 out, which will give us 2 plus or minus I square root of 11 all over 4. These 4's cancel, so our final roots become 2 plus I root 11 and 2 minus I root 11. So ultimately, what are our roots? Well, we have x plus 3 over 2. We have x plus 2 plus I root 11 and x minus an x plus 2 I root 11. Sorry, x plus 2 minus I root 11. I hope this video helped. If you have any questions, let me know. And as always, happy studying.